We are going to be solving each of these quadratic equations using the square root property, which means that we have to use our elements of solving a regular equation first, which means getting rid of anything that's added or subtracted, and then dividing or multiplying. And finally, once we have our squared term by itself, we'll do the opposite of squaring, which is square rooting both sides. So in our first example here, we'll need to get rid of the 16 by adding 16 to both sides. And that gives us a squared equals 16. Now that a squared is all by itself, we'll need to take the square root of both sides. The square root of a squared is a. And we know the square root of 16, it's 4. But before you write your 4, you need to remember that whenever you take the square root of both sides of the equation, you have to put a plus or minus sign in front, because there are two solutions that could be A. We could have positive 4 or we could have negative 4. The reason for that is if we were to plug in these numbers, when we square it, it gets rid of any negative number that was there before. Negative 4 squared is positive 16, and 16 minus 16 is 0. Positive 4 squared is positive 16. Same thing. Minus 16 is 0. So we have to include both solutions. This represents 4 and negative 4 being a solution, but we use this plus or minus sign instead of writing out both. And in example 1b, we'll subtract 49 from both sides. That gives us b squared is equal to negative 49. And when we go to square root both sides, we have a problem here. We have not learned how to take the square root of a negative number yet. In fact, if you try to put it into your calculator, you would get an error called non-real answers. That's because every number we have learned so far in our math career is called a real number. All positive, negative numbers, zero, fractions, decimals, irrational numbers, rational numbers, they're all part of the real number system. But the square root of a negative number is part of a whole separate number system called the complex or imaginary number system. And we don't learn about that until we get to algebra 2. So instead, when we get to the square root of a negative number, we write no real solution. You have to include the word real because there is a solution, so we can't just say no solution. The problem is there's just not a real number that will work as a solution. Let's look at example 2a. I have to add 22 to both sides. Remember, we get rid of addition and subtraction first. That leaves us with 8c squared equals 72. Then I have to do any multiplication or division. So I have to divide both sides by 8, leaving me c squared equals 9. Now that our c squared is alone, we can square root both sides, giving me c is equal to, remember we square rooted both sides, so I have to put plus or minus, and the square root of 9 is a perfect square, it's just 3. Let's take a look at 2b. We will add 17 to both sides of the equation to get rid of our addition subtraction. Then we'll divide by negative 3 on both sides. And when I go to take the square root of both sides, I'm left with the square root of 0, which is just 0. And putting a plus or minus sign, while not wrong here, is extra information. It's the only exception here of where we don't put a plus or minus sign, because positive and negative 0 are both the same thing. They're just 0. It's not considered a positive or negative number. Let's look at example 3a. We'll add 5 to both sides. So 3f squared is equal to 18. Then we'll divide by 3 on both sides so that f squared is equal to 6. Then finally, we'll square root both sides of the equation. So f is equal to plus or minus. Oh, but 6 is not a perfect square. So instead, we have to at least try to use our factor tree or our ladder method. So I'll use the ladder method on this one. And a prime number that goes into 6 is 2. It goes in 3 times. Prime number that goes into 3 is 3, and it goes in 1 time. Unfortunately, I'm not left with any pairs. So square root of 6 stays exactly as it is. In example 3b, we'll subtract our 35 from both sides, leaving 4g squared equals negative 12. Then divide by 4 on both sides. G squared is equal to negative 3. When I go to square root both sides, I notice that I have the same issue that I had above. I have g equaling the square root of a negative number. And we can't have that because we don't know how to do that yet. So we will say no real solution for this one as well. I added 2 problems on the bottom here. So if you don't have them, make sure that you write them down. We'll add 48 to this one on both sides so that x squared equals 48. Then we'll square root both sides of the equation to give us x is equal to plus or minus, but the square root of 48 doesn't come out to be a nice number because 48 is not a perfect square. So instead, we'll use our factor ladder, or you can use a factor tree. A prime number that goes into 48 is 2, goes in 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. And 3 is a prime number. This time I'm left with 2 pairs. So I'll have the square root of 2 squared and another 2 squared and then a 3 left over. And when I take the square root of 2 squared, I have 2. Square root of 2 squared is 2 again. And then the 3 stays over. Notice how the plus or minus goes in front of the problem. 2 times 2 is 4. So plus or minus 4 square roots of 3 is my answer. For our next one, we'll add 3 to both sides before we do anything about our square. We'll have to then divide by 2 on both sides. Then we can square root both sides. And remember to put our plus or minus in front, but we know that the square root of 20 does not come out nicely. So I'll need to use my factor ladder or the factor tree, whichever one you want to use. 2 goes into 20 10 times. 2 goes into 10 5 times. And 5 is prime. So this time I have only one pair and a 5 left over. So plus or minus the square root of 2 is 2, and here's 5. So I have plus or minus 2 square roots of 5 as my answer.